Alright guys, and we're back with a little bit more math YouTube action. Today we're going to be talking about learning target number 9, which is solve linear equations in one variable, including equations with coefficients represented by letters. We're actually going to focus on the first part of that learning target, and the second part, the solving equations with coefficients represented by letters, and we're going to leave that for a different video. It just makes it easier to split that up into two different parts. I'm going to walk you guys through this example that I have right here, and I actually have another one written down that has some fractions in it. And the way we're going to solve it is by using this procedure that I came up with. The procedure that you see listed here is probably not listed anywhere in any kind of mathematical text. It's just a procedure that I came up with to help you guys, to help make it easier for you guys to solve equations and find that starting point. And it almost works like a checklist as you're working through this procedure, each one of these steps. So first step would be, if there are parentheses, get rid of them. You may need to use the distributive property for that. Step 2 is, if there are fractions, clear them by multiplying each term by the least common multiple, and we're going to refer to that as the LCM. Number 3, if there are like terms on the same side of the equal sign, combine them. And then finally, number 4 is solve the equation using inverse operations. This procedural list that I have listed here may or may not be the fastest way to solve the equation. Right now, I'm not really concerned with you guys finding the most efficient way. You guys are so new to this that just being able to do it in any way possible is good for now. If you find a shorter way of solving an equation, and you didn't follow this procedural list, that's perfectly fine as long as you get to the correct answer, which is what we're concerned about. Sometimes you will not have to use every single one of those steps. In fact, when you're solving some of the equations that we initially started doing at the beginning of this topic, you'd start at step 4 and just use inverse operations. But as the equations got more and more complicated, it made us have to do some of these things that I listed off in steps 1, 2, and 3. But in any case, let's go ahead and get started and solve this equation. Now it's we have 3 times quantity x minus 4 equals 6x minus 2 quantity x plus 7. So our first step says, if there are parentheses, get rid of them. You may need to use the distributive property. And we totally have parentheses here, so what I'm going to do is I'm going to distribute the 3, and I signify that using those arrows, and I'm going to do the same thing with this negative 2 over here to each piece. So 3 times x is going to give me 3x. 3 times negative 4 is going to give me negative 12 equals. The 6x remains. And then something to take into account here is a lot of times people forget to distribute that negative. It's negative 2 times x. Whoops. And then negative 2 times positive 7, which is going to be negative 14. Okay, so we've actually taken care of that first step. So we can now move on to step number 2, which says, if there are fractions, clear them by multiplying each term by the least common multiple. We don't have fractions here, so we can actually skip that step, or I can just put a little check mark and say, hey, there's no fractions. I don't have to do anything. I can just move on to step 3. Step 3 says, if there are like terms on the same side of the equal sign, combine them. Well, let's check. On the left-hand side, our equal sign is right here. On the left-hand side, I have 3x and negative 12. These are not like terms. And on the right hand side, I have a 6x and I have a negative 2x. Because those two terms both have an x there, they're like terms. And then I have negative 14, which I cannot, there's nothing else for me to combine on that side. So I'm just going to leave it. I'm going to rewrite the whole equation. 3x minus 12 didn't change. And then I'm going to take 6x and I'm going to take away, and I'm going to combine it with negative 2x. 6x and negative 2x are going to make 4x minus 14. Something to note, when you guys are combining like terms, make sure you do not use inverse operations. Because we're on the same side, we just combine them. So something common that I tend to see kids do is they'll add 2x here and they'll add 2x here, which would be incorrect. The equal sign is right here, and we're trying to maintain balance between both sides. And what you've actually done is add a total of 4x to this side. If I wanted to do this, I would have to add 2x twice to this side, but we're not going to get into that. Just know that when the terms are on the same side of the equal sign, we just combine them. So we have no more like terms on the left-hand side or the right-hand side, so we're done with step number 3. And then the last piece just says solve the equation using inverse operations. So all I'm going to do now is I have like terms, they're just not on the same side, like this 3x right here and this 4x. They're alike, they're just on opposite sides. If I want to combine them somehow, then I'm going to use that word combining very loosely. I'm gonna use inverse operations. I'm going to go ahead and subtract 3x from each side. You could have also subtracted 4x. I just like to have my term with the variable, I like to keep it positive. So since 4x is bigger than 3x and I knew I was going to subtract it, I subtracted 3x from each side to make sure that I was going to end up with a positive x. So I got the equal sign is still there. This is 0, and then I'm left with negative 12. 4x minus 3x is 1x, which I'm just going to write as x. I don't have to put that 1 there. And then I'm going to bring down that negative 14. Okay, so I haven't actually finished solving this. I got to take I think it's one more step here. And we're still working on step 4, which is solve the equation using inverse operations. Now remember, the idea is to get the x by itself on the left-hand side or on the right-hand side. So we have this negative 14 here, and that's kind of disrupting what we're trying to do. So what I'm going to do is I'm going to add 14 to each side. Plus 14 plus 14 to this side. Okay. Negative 12 plus 14 is going to be a positive 2. And then I'm left with x. This turns into 0, and I'm just left with x equals 2. Okay, so it all worked out for us, luckily. Now all you'd have to do is you'd have to go ahead and check to see if your answer is correct. Actually, you know what? I forgot to put a check mark here. We already solved this equation. So what I'm going to do here is I am going to plug this value here back into my original equation. So I have this here. I'm going to plug it back into this original equation. So I have 3, and I'll make it green. So this is my solution check. So I have 3 times, and I have parentheses. I have x, which x was 2, minus 4. And then I'm going to put equals. I'm going to put a question mark over the equal sign because I don't know if it's true or not yet. That's what we're trying to see. And then I have 6x, 6 times 2, minus 2 times 2 plus 7. So I'm going to simplify down this left-hand side and then simplify down this right-hand side to hopefully give me the same thing on both sides, which is going to let me know if this solution that I got is correct. So I'm just going to go ahead and follow the order of operations. 2 minus 4 is negative 2. Negative 2 times 3 is going to be negative 6. And we're going to see, is that in fact equal to, I'm going to have to do a little bit more work here. Let's see, 6 times 2 is 12. 2 plus 7 is 9. 9 times negative 2 is negative 18. Negative 6 is equal to 12 minus 18 is negative 6, and it works. So our solution of x equals 2 is going to be the correct solution.